don't think I touched it. I just knew I was going to touch it. So this is me. That was a scary picture, but it's actually of the scary picture here. Does anyone know? And this is the universal biohazard symbol that I put on top of what this is. Does anyone know what this is? These are red blood cells. That's HIV. So it's a cartoon, obviously. Viruses are actually much, much smaller than red blood cells, but so we didn't get the translation to work.
No, I was hoping Cindy would have information, and she didn't.
Okay.
So.
All right. So before I get started, I will try to go slowly. Please stop me at any time if you have any questions. You don't need to wait till the end. It is kind of dark in here, so. Yeah, I guess that's about it. We don't have the translation service, so I hope that the recording helps if you have trouble with what I'm saying. And I hope that I'm trying not to use a lot of really technical terms, but if you need anything explained, please don't hesitate to ask. Okay, so I'll just introduce myself. So I'm the biosafety officer. I've been in this position 8.5 years. I did my PhD here in host pathogen interactions, like really how a particular bacteria establishes colonization in people. And so I started my graduate studies in '99, graduated in 2005, and I've kind of been around ever since. So I'm really familiar with this area, with this campus, and with our labs and what we're doing. So a little bit of what I'm going to go over. So this is a really broad spectrum, and I'm not really going to go into a lot of depth on any of these things. I only have actually 25 slides, I think, so it's not a very long presentation. So I'm going to go over the bloodborne pathogens, what it is, what they are, what it means for you, other body fluids too, other than blood, and fleas and bed bugs, which people might come into contact with if you're in the housing areas. How to clean up a spill of body fluids, any kind of liquid it works for, but for body fluids in particular. And then finally, the laboratories. How many of you work in the laboratories or in the science buildings? Okay, yeah, so it's just a handful, but we had some problems right around the holidays last year with some really there was bad behavior on the labs. The labs were leaving things they shouldn't leave behind, and so we started talking about doing this training back then for that purpose. But because of the union, you all have to have the same trainings, and I understand that you guys can move around quite a bit in your jobs, so maybe you might, if you're not in a lab now, you might go into the labs. And I hope what I'm going to try to communicate with you is that the labs are safe. They're not a scary environment. Yeah, so I'm going to talk about that a lot. And actually what happened in the lab where this bad behavior happened, so for those of you that don't know, the professors write grants and they fly around the world and give talks, but they don't actually work in the labs. It's the grad students and the postdocs that do all the work in the labs. And so this one professor, it's kind of a funny story, that's why I'm telling it. So this one professor actually had been out of the lab for about a year, and she came back in the lab and was furious with the amount of clutter and things that had piled up in the fridge and the freezers. And so she went on this cleaning binge, and then there were just piles of biohazard bags of waste that she basically left hanging out. And then the custodians came in that evening and didn't really know what to do with this stuff, which was rightfully so, right? So anyway, we had a lot of conversations about it. It actually rose to a pretty high level. Okay, so bloodborne pathogens is the first part of this. So there's a regulation for bloodborne pathogens, and I had this little abbreviation BBP, which is on probably some of the slides here. But it's just a shorthand for bloodborne pathogens. So it's a regulation at both the state and the federal level by OSHA, and it applies to all workers who might encounter, who have an expectation of encountering blood during their regular work duties. Now, does that apply to custodial crews? No, not really. It was really written for healthcare workers. You know, if you're working in a hospital, you can assume you have a good probability of running into blood during your duties, right? But we feel like there's enough of a probability that we want to give you some overview of what it is and just some information. So this is really just a knowledge training. So as far as what the regulation is concerned about, it's really 3 agents: hepatitis B, hepatitis C, and HIV. HIV causes AIDS. If you're in my generation, that's what everybody was afraid of. Everybody was terrified of AIDS. These days, it's really very easily managed. I have a friend who's an infectious disease doctor. Ooh. All right, it matches my HIV. So anyway, I have a friend who's an infectious disease doctor, and she actually has had to deliver some diagnoses of HIV. And she said these days, in the field of medicine, they consider that about like a diagnosis of diabetes because it's so manageable. Does that mean you want it? No. But it's easily managed. The good thing about it is HIV, as well as hepatitis C, they are wimpy viruses. They die really quickly outside of the body. Even if they're still in liquid blood, they won't survive very long. They'll survive a little bit longer in liquid blood, but not really on the order of minutes, right? So it's very quick that they die. But there's no vaccine available for them. And hepatitis C, there's also some pretty good treatments out there these days. They're expensive, you don't want to get it, but they're out there. Hepatitis B is really a very hardy virus. It survives outside the body for a very long time, even on dried surfaces, like 21 days. So it can survive for a while. The name hepatitis has to do with the disease they cause, absolutely nothing to do with the biology of the virus itself. But for hepatitis B, there's a vaccine available. It's safe and it's very effective. Again, the standard was really written for healthcare workers, really largely for hepatitis B. And since the vaccine became available in 1994, occupational exposures to hepatitis B or occupational infections from hepatitis B dropped about 95%. So there are other bloodborne pathogens out there, of course. Ebola is a big one that's pretty famous. Marburg, Zika, Lyme, West Nile is another one. A lot of them require vector transmission, and what that means is something to transmit it from a reservoir. So West Nile has a reservoir in birds. It's transmitted through a mosquito to people. Zika also mosquito-borne. Lyme, ticks. So the point of me saying that is that everything, any kind of bloodborne pathogen can only infect you. It has to, if it gets into your blood. So everything has to get into your blood some way. And so the ways for bloodborne pathogens to be transmitted into your blood are through some sort of a syringe or a stick or a mosquito, or something that can actually poke into your bloodstream, or splashes onto your skin if you have wounds on your skin. If your skin is intact, it's a pretty good barrier. And then, there's also kind of microabrasions sometimes on your skin that people aren't aware of all the time. You can also get it by splashes to your mucous membranes on your eyes, nose, and mouth. HIV, since again that's what we're really worried about a lot of times, mostly. I mean, I think it used to really be a very kind of an emotional response to it because a death sentence. But it's really, really, really difficult to transmit it with a needle stick. Hepatitis B, not so much, but HIV is really difficult to transmit with needles. It really, truly is a sexually transmitted disease, and mostly through male-to-male contact. Okay, so how you protect yourself is just putting a barrier between you and the material. It's what we call universal precautions. On the far right there, I just have gloves. That's the end of the spectrum where you are in your day-to-day work. In our laboratories, we ask people to wear a lab coat and safety glasses as well as their gloves. This is mostly just because they're working with chemicals or they're working with infectious agents and they can splash it on them. And we want them to be able to take off their coat and send it into the laboratory laundry and not carry any kind of contamination home. And then the eye protection is obviously because they're hitting large volumes of liquids. They also, the chemists, they can blow things up. Not really, well, we don't want them to blow things up, but, incidents do happen. So that is, eye protection is warranted. This over here is kind of the extreme. This is actually not a real patient. They're doing a training here for an Ebola patient. So a few years ago when we had the Ebola outbreak and there were 4 patients in the United States, and Emory Hospital had 2 of them. They had 2 staff people with each patient 24/7, and there were 2 people that backed up each of these 2 people, waiting in the ante room so that they could relieve these people to go to the bathroom or whatever. But so they're in this whole isolated little bubble here to protect them from the Ebola, and it worked because we had 2 patients. They survived the infection, and there were no hospital transmissions in that situation. So universal precautions can be a scale, but basically it's just putting a barrier between you and whatever infectious material, or potentially infectious material. So how would you clean up a blood or body fluid spill? So here's your blood spill, and then I made these little cartoons. So I'm showing paper towels to cover up the blood here. But I understand you guys have like a powder or some kind of a thickener that absorbent material that absorbs the liquids. Okay. So either way, basically you just want to cover the surface. If you're using towels, use plenty of them. And let it soak up from the bottom. Don't smear it around like this. Just apply the material to the top, towels or absorbent, whatever it is. And then if you're applying a disinfectant, you want to apply it in a spiral from the outside in. And apply plenty of the disinfectant, whatever it is. Or just, you really want to saturate whatever that is with your disinfectant. And then you need to leave it on for the appropriate contact time. If you have a proprietary thing, you should read the instructions and understand how long it says. It should instruct you on the contact time. Bleach, we use 10% bleach in the laboratories, and it's 10 minutes. Kills just about everything. Okay, syringes. So we have had an increase of finding needles around campus. If you find one like this that has its cap on, there's nothing there that can stick you. It's absolutely safe. If you find one like this that has the needle off, obviously that's the cap off, that can stick you. If you find it with the cap next to it, do not try to recap the needle. You're way more likely to stick yourself with the needle than to actually get the cap back on. So, if you're picking up needles, we also recommend, this is a little controversial, so you can do what makes you comfortable, but it's actually recommended not to use any gloves because you have more dexterity without the glove, and you're more likely to drop the needle or do something, flip the needle or it can slip out of your hands if you have on gloves. So it's recommended you use your bare hands and pick it up by the barrel. And if you pick up a needle without the cap on it, you put it needle first into the sharps container. So sharps containers are engineered containers. So this one is a little bit better engineered. They're actually made so that when you put the material inside, it can't come back out. And once the top is sealed, you're not supposed to be able to open it up. And the fill line is 3/4. So this one's really obvious. This one's not so obvious, but there would be a fill line on here about 3/4. So have any of you found any needles around? Okay, so I've gotten calls from the library. other places about the public bathrooms. You know, they might be just diabetics injecting their insulin. And we've talked about putting sharps containers in the bathrooms, but that's a huge project because you have to, if you've seen them in airports or other public areas, they're like secured to the wall and locked into the walls. So it's become kind of a big campus project that, you know, hopefully we'll get something soon, someday. Okay, what about poop and vomit? So these aren't covered by the OSHA standards, by the bloodborne pathogen standard, unless they're visibly contaminated with blood. So you don't have to worry about blood in these things, but clearly, you know, people are concerned. There are a lot of things that can be carried in poop. Not so many things in viruses, in vomit. Vomit's gross, but there's not really a whole lot, other than maybe norovirus and astrovirus and some of the things that cause you to be really uncomfortable for about 48 hours. But it's really the same thing applies. You just want universal precautions to put a barrier between you and the material. Gloves. Someone earlier asked about unclogging a toilet, and I would recommend in that case wearing a face shield to protect your face from any splash back, or at least safety glasses. You could also get disposable gowns and that kind of thing, you know, if you want to protect your clothing. Do you have a question? Or you just... Okay. Oh, oops. What did I do, Pete?
I don't know, hit escape first. And then I hit the arrow.
Okay, thank you. No, that went too far. Okay, fleas. Okay, so we have, I'm sure you all know, there's a huge increase of service animals on campus. Those include some that are living in the dorms. And they actually have a contract before they can bring them on the campus that they'll have parasite maintenance, but you know, it's not 100%. So we do have fleas. We've had flea infestations in the dorms. We've had probably fleas other places. We're out in the woods. You can carry them in on your own pants. So a lot of people ask me what types of diseases can be transmitted by fleas, and really not much, but plague. Plague is transmitted by fleas, and it is present in California, and there are little outbreaks of it every year. And it's really easily treated by antibiotics once they identify what it is. This is a map of California, so a survey of the plague from 1984 to 2013, so a long years there, 30 years. And the point here is that most of it is in the Sierras and down south. A little bit up around the city, but not in this area. It could be here. It's present actually in ground squirrels. They're the reservoir. So it's possible, but very, very unlikely. And easily treated if you get it. The other thing that they can carry is murine typhus. And that is, you know, it's a similar kind of thing. It makes you sick, aches and pains, fever, chills. But last year there were 14 cases in California, and they were all in Southern California. So they're not around this area for that particular disease. Fleas, really they don't transmit that many things. Bed bugs, not known to transmit any diseases. Are they disgusting and nasty? Yeah. But what I recommend, if you're ever in an environment that might have bed bugs, is the same thing if you're hiking out on the trails. It might get ticks on you, and that is to have a change of clothes. To put a change of clothes, and this is your undergarments as well, in a plastic bag, tie it tightly, take it home and put it in the washer and dryer immediately, and shower as soon as you can. You know, most of the time, if we have these things, we have contractors that come in and take care of it. But if you encounter something that you're concerned about, I hope this gives you some peace of mind, at least for diseases. Finally, if you're seriously ill, consult your physician. and tell them what you've been doing. Now, if that's both your work related, or like I said, if you've been hiking in the Sierras and found a tick on you, it's really important to communicate that to your healthcare provider so that they can address, so they might be able to narrow down if you have an infectious disease. And of course, if it's work related, you will want to notify your supervisor and report that through the Employer's First Response Form, EFR form. All right, the labs. Does anyone have any questions on the other stuff? Okay. So, what scares you about the labs? Okay, there you go. You know, most people, I think Pete was saying, most people are afraid of aerosol breathing things in when they walk in to the lab. And in terms of the biological agents we have, there are no aerosol transmissible agents on campus, so you're not going to get anything just by walking through in the air. The chemicals also, if we have any kind of hazardous chemicals with a respiratory, any kind of inhalation hazard, we handle them in ways so that they're not in the air if they're being handled appropriately. We do actually have the toxin on campus that we think is behind the zombie myth historically, but it's locked away. You couldn't accidentally prick yourself with it. Okay, so biological agents are classified in risk group 1 through 4. Risk group 1 are things that don't usually make anyone sick, a healthy person sick. Risk group 2 are things that can make someone sick, but it's not a serious or lethal disease. Risk group 3 are agents that can be lethal if they cause an infection, but there's usually a treatment or vaccination for them. Tuberculosis is a 3. The agent that causes plague is a 3. And risk group 4 are things that are lethal, that are highly contagious and lethal. There are no bacterial spores, they're all viral, and that's like the Ebola, Marburg, those are the bad guys. So in the laboratories, how we contain them is in biosafety levels. So similar biosafety level 1, that's almost all of our labs. Biosafety level 2, we have a handful of them here at ECSC. 3, there aren't any at ECSC. There are some at our other campuses, but not here. And in BSL4, there aren't even in the state of California. So they're very rare. There are a dozen of them in the country. And so really what defines the biosafety level is the containment practices, so that how we can work on these agents safely. And why do we work on these agents? And it's so that we can study them and understand the infection process so that we can come up with better treatments or vaccinations for healthcare. So this is a common thing you see in a biosafety level 2 lab. And I just wanted to bring this up. So I've used this diagram for the physical plant because they like diagrams with airflows. But really I wanted to point out though that anything that they're working with, if they're working with infectious agents, they're doing it in this biosafety cabinet. So everything is contained within that cabinet. And beyond that, it's even contained within whatever containers they're using, the tubes or the plates or the flasks. That's where the material is. If they have a spill outside of that containment, they're trained on how to clean it up, very similar to what I just showed you, only with bleach instead. So, because it's cheap, bleach is cheap and readily available, and they go through a lot of it. Because they also routinely decontaminate all their work surfaces at the end of the day, and often before they start too. Yeah, so my point there is the materials contained. So here, this is not a pretty slide, and it actually goes to a video that just goes into a little bit more detail, and I just wanted to show you that this is how I train the researchers how to clean it up, and it's exactly what I just told you. You put the towels on top, put the disinfectant on top. 10%, not 20%, 20% is not as effective as 10% if you're using bleach. We had a lot of questions on that earlier. So this is bad. All of these are bad. So first of all, if you're in a laboratory and you see any kind of this one's not so bad, but this is someone's working with this material, and so it's in the lab. It may or may not supposed to have a red bag. The red bags all have a biohazard symbol. We have clear bags also that have a biohazard symbol. They're actually not biohazardous, it's just biological material. The red bags usually do have what could be infectious or potentially infectious. This is really bad because this stuff is just sticking out. Oh, I forgot my pipette. Oh, I had one of these to show you and pass around because if you see these, they're long, they're plastic, they have a kind of a pointy end, but it's not nearly sharp enough to penetrate skin. But if you have some force behind it, it can push through the plastic. And they do sometimes, and that's important in the next slide. This is what I was telling you about earlier, where that professor was on a cleaning tear, and she ripped everything out of the fridge and put it in these bags. This is terrible. This should be in secondary containment. It shouldn't be there at all. We had a conversation about it. The custodial services took this, actually the custodian took this picture and sent it to me, or it made its way to me, because they didn't know what to do with that, right? And clearly that is not something that should be removed. That's bad practice by the labs. So hopefully you won't see this. So what she was doing here, actually, as I said, she went on this cleaning tear and she put everything on this cart, and she'd already done one run through the autoclave, which I'm going to explain in a minute. And then she went home, and then she left that there overnight to come back and put it in the autoclave the next day. So autoclaves are what we use to sterilize things, and that sterilize means actually, so sterilizing something means everything is dead. It is sterile, right? You can put this in a medical implant. It's sterile. Disinfecting is sort of like just surface cleaning. Like you kill a lot of things, but not everything. Sterilize there is nothing alive in the material. So we use an autoclave to do this, to sterilize waste and actually some of the media that is used. And it uses a combination of both heat and pressure and a long time, 45 minutes at 21 pounds per square inch pressure and 120 degrees Celsius. So that's really high heat and pressure. 120 degrees Celsius, the boiling water is 100 degrees Celsius. So the pressure will keep any liquids from boiling over, but that's to give you an idea of the intensity inside of that chamber. So once the autoclave is sterilized and not just disinfected, and we also maintain the autoclaves to make sure that they're working properly, and we have to document these records with validation testing and calibrations. So this is just a picture of the autoclave in use. It's got all these dials and things on it. So this one here is this one that's in the middle, and this shows you the pressures at 21 psi, and then this is the temperature wheel that shows, this is the green one's the one that moves on the bottom, shows that it's at over 120 C. This also swings out and shows that it's over 100 degrees. So you put it on sterilize for 45 minutes, there's 25 minutes remaining, and then you can't really see this very well, but there's a red light here that shows it's sterilizing. Once the run is done, this green light is exhausting. So I guess my point is here, if you see one of these running, just don't touch it. They'll be warm on the outside. They're not hot enough to like really burn you on the outside because there's a jacket around them, but not a good thing to mess with. So when things go through the autoclave, they're labeled with autoclave tape, and so that's an indicator for everyone that it's been sterilized, whether it's media or flasks or waste. And so before it's gone through the autoclave, there are these kind of white marks. After the autoclave, it turns to black. So it's pretty obvious when it's changed. So here's an example of waste, and I mentioned that there could be clear bags or red bags. So my understanding now is that once they run things through the autoclave, they put them in these metal cans, and then those can be removed. Now here, I took this picture yesterday, it's in one of those metal cans. I don't know where the autoclave tape is. It might not be visible, but don't mess around and, kind of start to, just leave it be and remove it. Don't look for the autoclave tape. The labs are trained. These are actually pictures that I used to train the labs. They are trained to either tie the bag into a knot or to gooseneck the bag and tape it closed. So it should be securely closed so that if it's inverted, the material won't fall out. Now, this is where I want to mention, though, that the serological pipettes sometimes can poke holes through the plastic. And here was another bad incident where that's exactly what happened. It's hard to see what's happening here, but there's this brown, yucky goo down here. And what that is, I know what that is. It smells too, it's stinky. It smells kind of like, I don't know, burnt beef broth or something. Yes? So, but it's media that they grow bacteria on, basically. Usually non-pathogenic bacteria, so nothing will hurt you. But this is bad. The lab shouldn't have left this. They may not have even known they did it, right? They probably just tossed their thing, their full bag into the can, and the pipette, certainly a pipette is what pierced through the inner bag and then the outer bag, and it left this goo on the bottom. And so this was another concern. The custodian took this photograph as well. And this was something that, it should be sterile, even though it came out of the autoclave, but I can understand why someone would be comfortable with that. And the lab should clean that up. That's not something that should be left for you. And so, we want you to not feel like you're putting yourself in danger for any reason. So I hope that I've explained to you that there really shouldn't be anything you would be exposed to. But if there's something you're not comfortable with, like something like this that you encounter that's unusual, notify your supervisor immediately. Take a picture if you can. And you can always, notify me. I don't monitor my email overnight, but I'll get to it the next morning. Melinda, is Melinda here? Oh, okay. Well, Melinda will certainly knows how to she knows how to get in touch with me. She sent me this picture. So, yeah, I think that's about it. Oh, there's one more thing. So I took this picture also for our trades people, the physical plant people. So if your buddy injures themselves, cuts themselves on glass or whatever, you don't know what they were doing in the 80s or the 90s. Maybe they weren't born yet. But my point is to promote self-care. So again, it's universal precautions. You can't transmit any diseases if you don't have contact with it. So help your buddy, give them Band-Aids, give them paper towels, give them hydrogen peroxide or whatever, first aid. But I recommend not handling their blood, if you can. So promote self-care, help them out, and let them know. Again, it's universal precautions. Don't touch whatever might be infectious. And blood is in general, we call it potentially infectious material. So, and with that, are there any questions? Yeah? No? You're all anxious to get going? Okay, well, if you ever have any questions, don't hesitate to contact me. You can email me at biosafety@ucsc.edu. Melinda, like I mentioned, I think all the night supervisors know how to get in touch with me. All right.